Good evening, everyone. Thank you for joining this webinar. I'm Spandana, a product associate here at Grey Campus. Before we get started, a few housekeeping notes. All of your lines are muted by default, but we will have some time in the end for questions. Please use the Q&A panel to post your questions. So coming to the webinar, chatbots are now used in every industry known to humans. With the increase in demand, the production of chatbots is likely to be increased. Let's look at how to deploy these models using machine learning. Today's topic is chatbots, ML model deployment in production. Coming to our today's speaker, it is my great pleasure to introduce our esteemed speaker and course advisor, Rajiv Kumar, who will be leading the session. Rajiv has over 22 years of experience in the IT industry and has worked with multiple Fortune 100 clients. Rajiv has developed multiple AI-enabled solutions in various fields, from fashion to education. His solutions have saved millions of dollars to his clients. Now, without further ado, I'm going to hand it over to Rajiv now, who will take us through this presentation. Over to you, Rajiv.
All right, thank you, Spandana. Thank you very much. All right, I hope everybody is able to hear me now. Yeah, all right. Thank you, Spandana, for confirming. Sorry for the delay. I just want to make sure I'm on the right network. All right, let's get started. So today's topic is focused on a machine learning model deployment. You know, what are the things that are involved in machine learning deployment? And we will also look at how, if we want to deploy our model as a chatbot, what will it take? Right. So that's what we are going to focus on. So just to kind of summarize what we are going to talk about. First of all, we're going to look at what are the options when we want to deploy our machine learning model. Right. So once you have trained your ML model, how you can make it available to the other people or other applications. Right. And we will look at some of the tools and techniques to deploy our ML models. And then we will see how we can use our ML model and deploy it as a chatbot in Slack. And now Slack is a very popular messaging platform, especially in the enterprise space. A lot of companies use Slack. So this could be a useful trick in terms of how do we make our model available in Slack as a chatbot, right? So we will look at that. And then we will also talk about what kind of things we need to do once we have deployed our model. What comes after deployment? Once your people have started using it, the role of ML engineer doesn't end there. It continues, and so we will look at what exactly we should do after deployment. All right. So now to start the session, so basically in this session, our focus is on ML model deployment. So when we talk about ML model deployment, so the first thing that where we start off is when you have a model. So in this session, we're not going to talk about how do we train a model. Rather, once you have trained the model, how do we make it available to others? Right? That will be the goal for this session. Now, your model, again, could be anyone. I mean, the tricks or the tools and techniques that we are going to review are applicable to any ML model that you will build. Right? It could be as simple as a sentiment analysis model, or it could be a more complex model like language translation model, like Google Translate. Right? So the steps that we are going to discuss here are very similar for any model, right? So that's the thing. So these steps are common across all ML models. So let's get started. So what are the approaches to model deployment? Now, how we can make our model available to the different applications, different people? There are two kind of approaches. One of them, which is more common, is server-based approach. And we're going to talk about server-based approach is basically where you put your model on a server and then ask people to connect to the server. And this is more common approach. But quite often nowadays, we have model deployment options where we are now looking to deploy the model on the client side. Now, what does client side means is basically you can deploy your model in a mobile phone. So when you are basically want to use the model, the client's data does not need to go outside of the mobile phone. It stays in the mobile phone. It uses the model right there, and get a response back pretty fast, right? Because there's no network latency involved. So this is also getting more and more popular in the industry, the client-side deployment. Now, it could be a mobile phone or a web browser, right? Now, in terms of server-based deployment, as basically you deploy your model on a server, just like usually like any other application. And quite often we have, we call this, server-based model, deployed model using REST API. How do we recognize REST API? Anytime you're dealing with HTTP, HTTPS call, you're dealing with REST API. And I mean, as you saw, most of our, web traffic is basically handled using HTTP or HTTPS. So in the same way, we can basically connect to the model and get results back from it. So that's a server based. Now, if you are, I mean, how do we basically, quite a popular approaches to deploy, or rather, what libraries to use when you're looking to build models for server. Quite often, you have, libraries like Scikit, which are quite popular for classical ML algorithms. And if you're building a deep learning model, TensorFlow is very, very popular in the industry and offers a lot of benefits in terms of different platforms where it can be supported. So we can use these two libraries to train our models, first of all, right? We can use train our models, and we can use same libraries to deploy it on the server as well, right? That's the thing. On the other hand, if you talk about client-side deployment, you basically the libraries like TensorFlows and all are very heavy in nature. So to make your model deployed on smaller devices like mobile phone, we use libraries like TensorFlow Lite or Core ML. These are TensorFlow Lite is a lighter version of TensorFlow, and it basically it doesn't take too much memory on mobile devices and allows you to run your model pretty fast, right? And TensorFlow Lite is supported both on Android as well as iOS. Similarly, Core ML is a library from Apple, so it is mainly supported on iOS only, but that's another option. Now, in terms of web browser, we can deploy our models inside web browser also. So what will happen? Your model also first gets downloaded to a web browser, and then it runs in the user's machine, not on the server. So in that case, if we want to do that, we basically can use a library called like TensorFlow JavaScript, very popular one. A lot of good work in that done in that space. Right. So we have quite a few options. So we have both client side as well as server side. Now, in this session, we're going to focus on a server-based deployment. How do we deploy a trained model in a server-based deployment? And what we will do, we'll make it available as a web service and any other application can connect to it using web service. Now, once you make it available as a web service, different applications can connect to it. So let's go with it. Let's understand what is involved when we are talking about server-based deployment. So in server-based deployment, it's essentially a two-step process. First step is we basically build a program. When we say Python module, we usually build a program to do the prediction. Just a regular program where, and we will talk about that. And the second module will be essentially where we build the web service. So what happens? We put this code, prediction code, behind our web service. So other application, they will just talk to the web service. And the web service internally will talk to our program and get the results back. And this is a very popular approach in terms of model deployment. So we will look at that, this thing. So once you do this way, I mean, if you follow this approach, it's a two-step approach where you build your Python module to essentially, do the prediction, and then wrap that module with a web service. Then what happens is you can support any kind of application with it. Right? You can have mobile phones connect to this application. You can have it's a browser-based application connect to it. You can have Java clients connect to it, or a application with Python, written in Python connect to it. So this makes it, I mean, because once you make it once you need just an HTTPS call, almost all languages, computer languages support making those calls. So effectively, you allow anyone to connect your model, of course, as long as that application is authenticated, right? I mean, authentication is important. That has to be taken care of. But it makes your life easier as far as making your model available to all the required applications, right? So we will look at these steps, and we will try to have this working in real time also. Like, let's see how it looks like, right? So when you're talking about, let's look at the step number 1, and this is again specific to the library which you have used to build the model, right? A machine learning model is nothing but the layers that you have used in the model, and what are the weights and by weights of those model, and you will basically need to use that. Now, for the first part, which is the building the prediction module, the thing is, it's again specific to every model. So essentially, you will need to carry out, before you can build a prediction module program. Essentially, you need to have a trained model. You also need what were the data pre-processing steps that you carried out when you train the model, like what are the normalization schemes, what are the padding schemes, or especially if you're dealing with a language model, natural language processing models, you need to have that tokenizer also available with you. And this is the tokenizer you would have used while training the model. Right? Those things will need to come out of training and will be used in a program. Now, once you have these things, it's fairly straightforward to write a prediction model. So the first thing you will do is load your model. Again, if you're using a scikit model, you can load it with Pickle. If you're using Keras model, you can load it with load model API within Keras. So it's again depends on the library, but that's one thing you will need to do. Load your model in the memory so that it is available to do the predictions, right? Second thing is you will be required quite often. You will do some kind of pre-processing on the data before feeding the data to the model, right? Pre-processing could require tokenization. In NLP model, tokenization is very common, or you will do normalization of data. So you will so whatever data pre-processing you did during training time, you will need to have the similar training pre-processing steps, data pre-processing steps in your prediction model, right? So once you have that, I mean, then you are ready to do the model prediction. You're ready to do the model prediction. So load your model, make sure you have a function to carry out all the pre-processing tasks, and then you start model prediction. So it's not very complex, but once you have the model, it could be just few lines of code and you're ready to go. So in this example, what we have done, we have a model which can read a paragraph, and then you can ask questions from that paragraph. So, for example, this is the paragraph, right? I mean, quite often we are required to do that. I mean, you basically read the paragraph, and then you will have a reading comprehension, okay, who was the, this is about, actually, this particular paragraph is about Google. So for example, you can ask when was Google formed, who are the founders, who is the CEO, and so on, right? Whatever information is there in this paragraph, people can ask in their own, right? So this is the model. Again, what we are doing, the example we take, the steps remain same. So the prediction module could be slightly different for each model because the pre-processing steps will be different, but making it available, deploying steps are going to be same. So in this case, we have the model and we have carried out these steps. We have a program where we load the model, we basically do the data pre-processing, and then we do the model prediction, right? So that we have that part ready for us, right? In this case, it will be a reading comprehension model. This particular step is the prediction module step is slightly, you can say will be specific to the model that you have built because of the pre-processing steps, right? Now, once you have your prediction module, which you are then ready to make, then what the next step will be to make it available as a web service. That is where the interesting part will start, and that part remains common to no matter what kind of model you have. So first of all, let's take a look at the model prediction module. So this is a model in this case, and so first we are doing is we're going to load the model, load the token, because this is an NLP based language based model. We're going to load the model and then carry out. Then we, in this case, we have done a predict function to do the pre-processing as well as model prediction inside this. But as I said, these steps will be very specific to each model. And you will know once you when you're training your model, you will know what are the steps that you carried out. So this particular one is not common to every model. So the pre-processing and how to predict is dependent on the model that you have trained. Now, once you have that, once you have this, then if you want to make it available as a web service, that part remains common. So let's look at what we can do to build a web service for our model. Right? So for building a web service, first of all, we need a web server. Essentially, you need to have a web server running so that people can connect to your web server. And then web server will connect to your prediction program and get the response back. So to build a web server, to start a web server can be complex or can be very, very simple. Now, what we will do, we're going to do in a much simpler way. What we're going to do, we're going to use a library called Flask. And there's a Python package called Flask, and this is a very, very light framework, which basically with just 5-6 lines of code, you can start a web server. And you will see, I will show you guys, in just 5-6 lines, we can start a web server. So this is literally 10-minute work, and you will have a web server running in front of your code. So let's see, how do we build a web server? How do we build how do we write a code to start a web server and in using Flask, and how easy it is, right? So let's take a look at that. All right. Okay, so I'm going to show you a program called predictionwebservice.py. That's the Python script to start the web server. And you can see, I mean, although it says 21 lines, but most of them are blank, I mean, or comments. We literally have just 4 plus 4, 5 or 9 lines here to start a web server. So the first line is basically where we are importing the prediction module that we built. The prediction module where you load your model, you do the function, pre-processing, and then you do the prediction. Here we are loading that, and then we are loading Flask. We are importing Flask in our program, and we are building a Flask object. Now, to tell Flask needs to know what should it do when it receives a web service request. The Flask needs to know what exactly what it needs to do when it receives a web service. So when somebody sends it a HTTP request, what should it do? So to do that, to make Flask understand what it needs to do, we have this decorator app root, and it's saying that for the default URL, when somebody comes to you with a default URL, just execute this function, get answer. Just execute this function. Now, what we are saying that in the function, when the request comes to will come, you will get a text field. Literary name is text field, and that text will be nothing but the question. And what you do, you pass that question to the model. Model is the other program that we have just created. So here we are connecting this other program, first program, with this web service program. Right? This model is nothing but that model prediction code that we have written first to load the model, to do the pre-processing, and do the prediction. So here we will call that code and get our answer. Okay? Very, very simple. And once we have that, then when we want to start, we will just say app.run. So app is the name of the Flask object. We are saying the app.run. And what it will do when we will execute this code, it will start a HTTP server, a web server on my machine on port 5000. So again, there's a port concept with web servers. So it will start listening on port 5000. Right? It's as you can see, only 6-7 lines of code will allow you to start a web server. Now, this code should be actually run on, in your production servers or on your, different data centers. You usually will work with your infrastructure team in your company, in your organization. Maybe you will need to deploy it in your organization data center, or they might rent compute on Amazon, Azure, or Google Cloud. So it depends depends on where you have been asked to deploy. But you can run this program on any machine that your organization is providing, as long as you have Python and these packages installed there. So right now, rather than running it on Google Cloud or Amazon Cloud, I'm going to run it on my machine. But the process remains exactly the same. So what I will do, I will start this. I hope everybody can see my command line prompt. And so what I will do is I'm going to start this web service code by saying Python, because this is a Python file, and I will just call the program name predictionwebservice.py. That's the code we just saw. This is you can see predictionwebservice.py. So we're going to start this. So let it run. It may take a few seconds, but you can see it has started a HTTP server, and it's, of course, it is running on my machine. So it says it's running on web IP address 127.0.0.1, which is actually the local host, and the port number is 5000. So our service is running. Our web service is running. Now let's go ahead, and what we will do, when our service is running, and you can see how easy was it to basically build a simple web service which will wrap the model behind it, which will put our model prediction behind it. Very, very simple. Now, let's go ahead and try to, as I mentioned, the same code what we ran here can be deployed on different platforms. It could be on Amazon, or it could be on Google Cloud. It could be on IBM, cloud or Microsoft Azure cloud or your own company's data center, right? So the steps remain same. It's just that who's providing you the machine, right? Right now I'm using my machine, but your organization might provide a machine on one of these options. Once you have the machine with Python and the scripts installed, you will, or the packages installed, you will just say Python and give the script name, and it will start the web server. So in our case, we have started the web server. So what we will do now is, this is what we did, start the web server, and we are going to test our web service. So let's try to see if I can test the web service. And so you can connect any language, you can connect to it from any language, code. So what we will do to test it out, we will connect it from, we will write a small Python code and try to connect to it, right? So let's try that out. So I have a simple notebook, and where what we will do, we are going to make a request to this web server. So let me show you guys how we are making it. So we have a function which says get answer from web service, to which we are going to pass a question. And what will happen? So what we will do, we will create an HTTP request, HTTP post to be more precise. And to the HTTP post request, we have to specify what is the server name, where the request should be sent. And now we saw that, of course, this is running on my local machine. So I'm giving the URL of my local machine. Now, later on, we will see how we can allow outside folks who are not able to connect to my machine, how they can connect to my machine little later. We will look at that. So, and then we pass that, because we have to send a text field to our server, and in the text field, we are passing the question, right? And if the request is successful, we are going to print it out. And if request is not successful, we are going to show the error message. And that's very simple client application we have. Again, this client application has no idea about model and all. It just knows it needs to send a question and to this address. This server will take care of the model prediction. Now let's try this out. Now let's ask our first question. So who is the CEO of Google? Who's the CEO of Google? So again, model will read that paragraph and try to answer. So let's see how the answer comes. And it says the answer is Sundar Pichai. It seems to be right based on that, that paragraph that we had. So model read that paragraph, it read the question, and it gave you an answer. All right, it seems like Sundar Pichai. Right? So we can see the request came to the server, and it basically processed that request. It actually asked the model to give to do the prediction and give back the answer. Now, just to confirm that request came, you can see that there is this, you can see there is an HTTP 200 completion code on my web server, web logs. And so it is there. Let's try one more. So let's say, who's the parent company of Google? Let's see if it can. And it says Alphabet, which is true based on the paragraph that is there. Right? So you can see, we are able to get answers. So our web service is running right now. Our web service is running fine. So now let's go back. So we tested our web service. It's running fine. But right now, you guys cannot connect to this web service, right? Because it's running on my machine, and I can play with it, but what is the point of it? And it's just with me, right? How do we make outside folks also connect to our model or our web service, in fact, right? Now, if you are basically right now, we have a computer where this model is running, and then you have people who want to connect. but there's no connection in between. So you guys cannot directly connect to my machine right now, right? You cannot. Now, how do I allow outside world to connect to my machine? Now, if you have deployed this model, if you got the machine from say Amazon, Google, or Azure, or even your organization data center, what will happen? You will get a URL, not the local host, but a URL to reach your machine. And that URL becomes, you can share that URL with whichever application wants to connect with your model. Right? That's how usually it works. But because we are demonstrating now, we are not putting it on a cloud right now. So in this case, now to allow people to connect to my machine, what I will do is I'm going to use a different service called ngrok. So there's a web service, there's a service called ngrok. So what ngrok does, ngrok is a company, which what it does, basically what it allows people to send their request to ngrok. Suppose you want to connect to this model that is running on my machine. So what will happen? People can send that request rather than to my machine. They can send it to the ngrok website, and ngrok will then forward that request to my machine. ngrok will forward that. You still cannot directly connect, but you can come to me through ngrok. And so once ngrok forwards the request, the web service will get it, the Flask web service. It will ask the model to process the question, and then what will happen? My machine or my web service will respond back to ngrok, because it knows only ngrok. It doesn't know that you have sent the request. And ngrok will then finally forward that request, or the response, to whoever called. Right? So we're going to use this arrangement. So we are going to put an intermediary in between. But this step is usually not needed if you are deploying it on your company's data center or one of the commercial cloud providers, because you will get a URL which you can share with other applications. So this is more of a test setup. Right? Now, how do I allow ngrok to forward the request to my machine? To do that, I will need to run a service on my machine, ngrok service. Now, how do I run that ngrok service? To do that, I will need to download a installation file, and it's easy. It's pretty simple step. You just download it, and an executable file is available, and you just run ngrok service on my machine. So how we run it? There's a command called ngrok http, and give the port number where ngrok should forward the request on my machine. Now my web service is running on port 5000. So we will write port 5000 here, so that ngrok, when the request reaches this service on our machine, it will forward it to web service running on port 5000. Right, so we will do that. So let's go ahead and let's run this step. I have already downloaded ngrok, and we will just run it. And it's as I said, it's as simple as ngrok http 5000. So so now when ngrok runs, what it does, it gives us a URL now, which is accessible from outside world. Right? So for example, this is the URL even you guys can use to send a request to my machine. This is the URL right now. Again, this will be available only for a few hours because it's free stuff right now, but you can buy a more permanent URL also if you want to. But it is available. It is this is the URL, and some of you guys are trying it out, and when you try it out, you are getting an error. Why? Because you are sending a request without the text field. Remember, you have to send the question. You're not sending the question, right? So you will need to send the question, and so for that you will need to write the code, right? You will need to write the code. But you can see my machine is actually accessible now, although you need to write the code to really make use of that model, but you are able to connect to our machine. Make sense, everybody? Yes, right? So now, of course, what you can do, you can try. I don't know if any one of you is using Python code, but you can write out this code if you want. I'm going to write it down. If somebody wants to try it out, and then you can try out this Python code. Right? This is the code, and then you should be able to get an answer back. So this is one way. Right now. Now this is so now one thing I made sure now my machine is available from outside. Now what we will do is we are going to basically make our model work as a chatbot because my model is now available on internet. So what we will do is we will make our model work as a chatbot, right? As a chatbot. So how do we make it work? So we need a messaging platform for the chatbot. So you have a lot of commercial messaging platform like WhatsApp, Facebook Messenger, MSN Messenger, or Slack. And I mean, your company might have your own messaging platform. So for demo purpose, what we're going to do is we're going to use Slack. So Slack is a messaging platform where it's more like WhatsApp for the corporates. So where basically people can come and you can have teams come in, they discuss with each other, and I mean that kind of stuff, right? So what we will do, we're going to use Slack, and we are going to add a chatbot there, add our web service as a chatbot, right? Now, how do we do that? So to do that, first of all, you will need to create a workspace. Workspace is more like a Teams a space. In Slack, think of it as more of a where you can invite people from your company or from your whoever you want to invite. And then you have channels. Channels are more like groups. Channels in Slack are more like groups, like WhatsApp groups, right? So you want to build a channel to discuss politics, want to discuss sports, and so on. Right? That's how it is. It's very similar to WhatsApp, but it's mainly Slack is more of a, you can think of a WhatsApp for enterprise people who actually are doing the work in the offices and all. They use it quite often. Right. So I have already done that. I have a Slack channel already open. So this is my Slack channel. You can go to slack.com and you can register. I've already registered, and this is my chat box. I mean, this is my group on the Slack where I can communicate. Right? So I have a test chatbot workspace, and I'm logged in there. Now, how do I add my model as a chatbot? For that, I will need to create a Slack application. Now, again, this is a big word, Slack application, but you will see that it's very, very simple. It's not very complex. So what we will do, our model is already running, web service is already running. We have a URL. That's all we need, and it's very, very simple to create an app in Slack. So what we will need to do, we will need to go to this website called api.slack.com, Slack apps. And I will show you how do we basically make our model run as an app or as a chatbot. So if you go to this website, you will see this, right? And I will just say create an app. And you will need to give a name. Let's say give a name like, let's say Jovi or whatever name you want to give. You have to give a name. Give any name. Ask about Google. Right? That's the name. And you have to specify which workspace you want to use it in. So I have a test chatbot. This is what when you will register on Slack, you will need to have a workspace. So say create an app there. Okay. So I think this needs to be asked about Google, and let's create an app. All right, let's say some simple what happened. Okay, I think I need to reload the page. It's been open for a while, so that maybe that's why it is, I think, re-authenticating. So let's say Jovi and a test chatbot, and all right, this time it worked. I think it was just the stale page has gone. So what we will do to create, we will create a very simple Slack app called slash commands, and you will understand why it's called slash. So when I click on slash command, it says, okay, create a new command. And in this case, I will just say slash, let's say Jovi. I'm just gonna give any name. Now, any name is slash ABC slash XYZ. You can just use anything. And you need to provide the URL of your web service. The same URL that I gave it to you guys, I will use that. That's the URL I'm going to use and put it there, because that's the URL where my web service is running, and Slack can contact my model on that web service. So this is the one I will use, right? So, ask about Google, just a description, and I will just save it. All right. And once you have saved it, it was as simple as that. And just you will need to install your app and just say install to workspace and allow. And that's it. Now you're ready to call our model from Slack, which is totally outside of my machine. So now let's see how we can use. Let me refresh our Slack page also, just to make sure it's not it's authenticated. So how do I contact my model from here? Is I will need to use that slash command. And if you remember, our slash command was slash Jovi, right? You can see it brought up that. Now ask about Google slash Jovi 8. Who is the CEO of Google? Right? So if I ask that question and you got an answer back from our server, Sundar Pichai, right? So you can see that it went to our server, got the response back from there. Similarly, let's say I want to ask another, where did Larry Page did his PhD? Right? And let's see, the answer is there, and it says Stanford University, which is the correct answer. Let me see if I can bring in some more questions rather than typing. We check that. Who are the founders of Google? Let's check that. Let's ask Joey. Who are the founders of Google? And it brings up those two names, Larry Page and Sergey Brin. Right? Right? So you can use it as chat. You can ask question to your model inside a messaging platform. Right? That's what chatbot does. It provides answers, solutions to things. Right? Let's try a few more. When did Google got incorporated? Right? So again, so because I can contact my model only by saying slash Jovi, that's requirement of Slack. So let's see what it was, and it says September 4, 1998. So it's doing a pretty good job there. Yes, absolutely. But Barki, you can go ahead and ask your question. We will take it up in a Q&A session we're going to have at the end. So definitely put out your question. So I'm just going to put it there. One more last, and apparently they have 14% stock of Google. And again, that's based on the paragraph. If it is different now, this guy will not know. It's looking only at the paragraph, right? So we can see this is how we can make our, what we saw is once we deploy our model as a web service, we can make it available to whichever application we want, including making it as a chatbot. Right? So this is how easy. You can see that the code was not very big. You just needed 6-7 lines of code using Flask. You start the web service and then you get a URL. And even in Slack, it was, I mean, kudos to those guys in Slack. They made it so easy to build an app, to build a chatbot. So you saw that just 3-4 steps, you're good to go. So this is how we can deploy our model as a chatbot, right? Now, once you deploy your ML models as in production, and either as a chatbot or as a normal web service, you cannot leave it just like that. The reason is, you need to keep monitoring the performance of ML model. Now, ML models are basically trained on data. So whatever data was used for training, that's where it learned it from. Now, quite often what happens in the real world, the data keeps changing. People keep bringing new thoughts, and if data keeps changing, what will happen? Your model will basically start performing poorly, right? Because it has not learned from the new data. So what you will need to do, you will need to retrain your model on regular basis with the new data. Right? Retrain your model, keep monitoring the performance of your model. And if it deteriorates, that means most likely the data is changing. Retrain your model on the new data as well. And once you have retrained, then go ahead and redeploy your retrained model, just like what we discussed, the steps we have looked at. And of course, you're going to repeat these steps 1, 2, and 3 on regular basis. These steps could be very common if you're working in finance, where data might change, say on daily or weekly basis. You might need to repeat these steps on weekly basis. If you're working in, say, healthcare, where data may not change, say in 6 months, 1 year, then you will not repeat these steps that often. Again, it depends on the industry. All right, so that's how we basically can deploy our models in very, very quickly by using a web service approach and making it available to outside world, right? And we saw how we can, once we have it as web service, how easy it is to make it available as a chatbot, and so you are all set. All right, so that's those are things I wanted to cover. If you have any questions, you please put it in your in the Q&A, and we will have we will take it up, answer the question. So there are a few questions in the Q&A. First is from Berke. So first question is a very interesting question, and I think it will be useful for everyone. The question is, how can I scale my chatbot? For example, if thousands of queries or questions come to my model, how can my model handle it? Right. So, and that's in a high in a traffic area, that's a real scenario. So how we handle it quite often is basically, I mean, if it's not 1,000, if there are few, then what you can do, you can have several instances of your model running, and just like we started one program, you can start multiple programs and have a load balancer in front of that. So that's one thing. But that may, if you have thousands of questions, you may not be, that setup may not even be sufficient. So quite often what we do is we usually handle it using, by using a queue management system. Queue management, where the request, when they come into to the web service, they will get placed in this queue, and you will have the code in your web service where the questions will be picked up one by one from that queue and then answered back. So that's first of all, multiple instances of your web service program running. That's one thing. Second thing is having a queue management system. So if you're using platforms like Amazon, Google Cloud, Azure, or IBM, these platforms offer you that service. Basically, they will scale up things for you, right? Or if you want to build your own, so there is a queue management, very popular queue management system called Celery. and you can look at that. But usually, Berkey, I would say is that I mean that's not a role of ML engineer alone. Quite often, you have to work with your infrastructure team in the company. If you don't have, then yes, look at Shellry, or I would say go with one of the cloud providers. They do have these services built in. They're offering like SageMaker or Google's AI ML engine. They do have those things built in. Okay, so that's the first thing. Second thing, anonymous, I guess that's from Sanan, will have access to, I believe you will get it. So that should be okay. You will have access to the presentation. The third one is, okay, again from Berkeley, do I need Kubernetes or something like that? Yes, you can make use of Kubernetes. I mean, again, see, Kubernetes is nothing, it's not specific for machine learning model. You can use it for any application, right? So if your preference is to use Kubernetes, I mean, definitely go with it. You can use Docker solutions, Kubernetes solutions with it. Again, it's not a must, but if your organization is yeah, has preference for that, you definitely can use those container mechanisms. Salary, yes, salary, yes, but yes, salary. So you can use it for ML model deployment as well, right? Okay. Yes. All right. Any other question or any follow-up question to those answers? Please do let me know. Or we still have 1 more minute. Any question, any further question? Definitely you have time. Otherwise, definitely you can ask any questions even later. You can drop a note to the support team. We have, you can reach out to the team anytime, even not just now. And here are the contacts. You can reach out on support@greycampus.com. That's the URL. That's the email to reach out. All right, so thank you very much, folks. Any other question if you have, great. Otherwise, we can close the session.
Great. Thank you, guys. We hope the session has helped you. For any questions or queries, please reach out to us at support@greycampus.com. Thank you. Stay safe.
Thank you.